So as promised, here is a tutorial on how to balance a redox reaction in a basic solution. So by basic we mean that overall, when all is said and done, it would test as a base instead of an acid. Alright, so here's our equation. This is the equation we're going to balance. First thing we're going to want to do is split the overall equation into two half reactions. So our two half reactions, the way to do that would be to assign oxidation numbers. So, because you need to know, what's getting oxidized and what's getting reduced. So I'll go ahead and do that for you. So there's all your oxidation numbers. You'll notice that manganese is going from +7 to +4, so it's being reduced. And it doesn't really matter that you know that it's being reduced to balance this. I'm just saying. And then, you know what? Sorry, I'm going to move this over just a little because I'm going to need the space. So MnO4 minus is becoming MnO2, and then leave some space, and then we'll do our C2O4 minus 2 is becoming CO2. I'm actually going to draw a line between them just so that we can kind of keep track of the two half reactions. Okay. So step number 2 is to balance the elements other than oxygen or hydrogen. So we'll come over here and you'll notice that we have manganese, but just one of them, and over here manganese. Those are already balanced, so we don't have to do anything to them. And over on the other side, the other half of the reaction, you have 2 carbons here, but only 1 here. So we'll go ahead and put a 2 there to balance the elements other than oxygen and hydrogen. Okay, now step number 3, we're going to balance this, or balance all the oxygens with water. So what that means is, and I'm going to do it in red, wherever we are lacking oxygens, we need to add oxygens, but we can't just add single oxygens, we're going to add it in the form of water. So here we have 4 oxygens on this side of the reaction, and on the other side you have only 2. So we need 2 more oxygens. So we're going to add that in the form of 2 water molecules. So that we have 2 oxygens here and 2 right here. So that adds up to 4, just like we have on this side. And let's look at the other half reaction. Again, 4 oxygens here, and then we already have 4 on this side, so we don't need to add any water to this half reaction. Alright. So again, it's pretty systematic. You want to just kind of have a system, or else it gets very confusing. So now we're going to balance any hydrogens that we might have added by putting water into this equation with hydrogen ions. So I'll do that in purple. So in this half reaction, we added these 2 water molecules so that we could get some oxygens that we needed. But now that's added 4 hydrogens. So we're going to go ahead and on this side of the equation, we're going to add those hydrogens into that side of the equation. And there's no hydrogen in the other half reaction, so we don't have to worry about it. So next step. Now, if this is in basic solution, so if this were an acidic solution, we would skip this step. But because this told us that we're in basic solution, then what that means is that we need to now go neutralize these hydrogen ions, because they're acidic, and this shouldn't be acidic. So we do that by adding enough hydroxide, and then this is the trick. You have to add it to both sides of the equation so that you can neutralize the hydrogen ions. So I'll show you what I mean, and we'll do this in green. So I added 4 hydrogen ions to this side of the reaction. So I want to neutralize that by adding hydroxide. So I need 4 hydroxide ions, and those 4 hydroxides will combine with these 4 hydrogens and produce water. So this really ends up becoming 4 water molecules. And because I added 4 hydroxides to this side of the reaction, I have to add them to this side. So I need to add 4 hydroxide ions to this side. Now notice, there's no single hydrogen ions on this side, so no water is made. And then, again, no hydrogens. We didn't have to add hydrogen ions to this side of the reaction, so we don't have to worry about it there. All right. Now, balance the electron, or balance the charge with electrons. So I'm going to go ahead and do that in blue. So backing up to this step, I prefer to take these and kind of circle them and combine them to form the water molecules right off the bat. And then maybe you can even just cross these out so you know that you don't really have 4 hydrogens and 4 hydroxides anymore, you have 4 water molecules. It's helpful if you do that right now rather than waiting till later, because then it just gets messy and kind of confusing. So what we really have is 4 waters plus NMnO4 minus yields MnO2 plus 2 H2Os plus 4 OHs. So now we need to look at total charge. On this side of the equation, we have a total of a -1 charge. Total. And on this side of the equation, we have 4 hydroxides. So we have a total of a -4 charge. So we need to add in electrons to even out that charge. The side that you're going to want to add electrons to is you're going to want to add them to this side, because you want to make it equal -4, and it currently equals -1. So I'm going to add in 3 electrons. And we'll do the same to this equation, which thus far has remained pretty untouched because we didn't have any extra oxygens to add, and so then we didn't have to add any hydrogen ions or hydroxide. So now we can finally start doing something to this side of the equation. So you'll notice there's a -2 charge. There's just one of these things, so there's a -2 charge total on this side of the equation. And on this side, no charge at all, so 0 charge. So that means we're going to need to add 2 electrons to this side to give it a -2 charge like the other side has. All right. So now we're going to multiply by a common multiple, and I'll go ahead and I'll do that in black to get the electrons on both half reactions equal. So you'll notice that this reaction has 3 electrons involved, and this reaction has 2. Now I would double check and make sure that your electrons are on opposite sides of equations, meaning that these electrons are on the reactant side and these are on the product side. If you have them both on the reactant side, you've done something wrong, or if you have them both on product sides, like if there were electrons on this side as well as this side, you've done something wrong, so you might want to go back and fix it. But notice that 3 and 2 are not equal, so we need to make them equal. So we're going to go ahead and multiply this entire equation through by 2. So I'm actually going to multiply this entire equation by 2 and this entire equation by 3. So I'm just going to rewrite it because I don't want it to be too messy. So 2 times 3 makes 6 electrons. 2 times 4 is 8 water molecules. 2 times 1 MnO4 gives us 2 MnO4 minus. And then we're going to go ahead and draw the arrow, and that gives us, so again, we're multiplying the whole equation, 2 MnO2 plus 4H2O plus 8 hydroxide. I'm going to move this up a little. And then this half reaction should be pretty easy. So 3C2O4 minus 2 produces or yields 6 CO2 plus 6 electrons. So the whole reason you did that is so that these equal each other. Okay. So now we're just going to go ahead and add the half reactions back together. But before we add the half reactions back together, I like to actually cancel out things. But that might be difficult for you to see. So let's go ahead and add the half reactions back together. So put these two together into one, and then we'll cancel out some stuff. So I'm going to go ahead and just do that in pencil. So we're going to take all of our reactants, and we're going to write them all in one equation. So 6 electrons plus 8 water plus 2 MnO4 minus plus 3 C2O4 minus 2. Okay. and then we're going to add in our products on the other side. So 2MnO2 plus 4H2O plus 8OH minus plus 6CO2 plus 6 electrons. Okay, so there's our overall reaction. And then, of course, the last thing you're going to want to do is cancel out the species that appear on both sides. So again, I like to do it up here, but we'll do it this way because, you know, it might be easier for you to see. So 6 electrons. Notice you have 6 electrons on both sides, so you can cancel those out. Here you have 8 waters on this side and 4 on this side. So these 4 will cancel, and that leaves us here with 4 waters. So we're subtracting these 4. We don't have MnO4 on both sides, so those stay. We don't have this on both sides, so those stay. And so overall, we're going to rewrite the equation as 4H2O plus 2MnO4 minus plus 3C2O4 minus 2 yields 2MnO2 plus 8 hydroxides plus 6 carbon dioxides. So that's your final answer. And the very, very last step, of course, is to check both sides of the equation for the same number of atoms and overall charge. So you want to make sure that the charge adds up on both sides, and you want to also make sure that the number of atoms adds up. So you want to double check that you have 8 hydrogens here, and you have 8 hydrogens here. You have 4 plus 8 plus, 12 oxygens. So 4 plus 8 is 12 plus another 12, 24 oxygens. So here you have 2 times 2, that's 4 oxygens, plus 8 is 12, plus another 12 is 24 oxygens, 2 manganese, 6 carbons, 6 carbons. We already did the oxygens. And then your charges. You have -2 plus another 2 minus, so that's a -4 total charge on this side. And oh wait, sorry, I forgot this 3. So 3 times -2 is a -6 plus these 2, so that's a -8, and then look, 8 negatives on that side. So your charges balance and your atoms all balance. So that's how you know you've done this correctly. So that's how you balance a redox reaction in basic solution. And of course, just notice that, you know, you have hydroxides left over, which is what makes it basic.